Okay. Section 7.2 is on similar figures, scale factors, and word problems. So today we are going to be working on identifying if two figures are similar to each other. So we have a few properties that we're going to be going over, and the first one is the reciprocal property. And if two ratios are equal, then their reciprocals are also equal. And if you don't know, a reciprocal of a fraction is that fraction flipped over. So if you had the fraction 2/3, the reciprocal of that is going to be 3/2. So we just flip the fraction over. What the reciprocal property tells us, if we have a fraction a over b that's equal to c over d, we can flip both of those fractions over and they're still going to be equal to each other. So we could say that b over a is equal to d over c. If we were to do this with numbers, we could have the fraction of 1/2 equals 2/4, and using the reciprocal property, we can also say that 2/1 is equal to 4/2, which is true. So that's what the reciprocal property means. Another property that we have is the means property. And this is if two ratios are equal, then their interchanging means yields another true proportion. So, for example, if we had a over b equals c over d, if we change the means, which is b and c, the ratio or the proportion is still going to be true. So if we had a over c, that would be equal to b over d. So an example, again, if we're using numbers, if we had the fraction 1/2 equals 2/4, if we swap the means, in this one, they're both the same number. So if we swapped it, we would get 1/2 still equals 2/4. If we did an example where they weren't equal, say we had 2/3 equals 4/6, and if we swapped those means with each other, we would have 2/4 equals 3/6, which is true because if we simplified this, we would get 1/2 equals 1/2. So that's what the means property is. And the last property we're going to go over is the denominator property. So what this one is if two ratios are equal, then adding the denominator of each fraction to its numerator yields another true proportion. So an example, if we started again with a over b equals c over d, if we take these two denominators, b and d, and add them to the numerators, the proportion is still going to be true. So writing that out, that would be a plus b over b equals c plus d over d. And this might seem like it wouldn't work, but if we test it out with 2/3 and 4/6, if we take our denominator 3 and add it to the top, we would have 2 plus 3, which is 5/3 equals, and then we would take the denominator 6, add it to the top as well. We would get 10/6, which is a true statement, because if we simplified the fraction on the right, we would also get 5/3 when we divide them both by 2. So by adding that denominator to both of the numerators, we will get an equivalent, or another true proportion. And that's the denominator property. Okay, and when I copied over the notes, it kind of got rid of the fraction bars. So for this, there's supposed to be a fraction bar there, so it should be AC over DF equals BC over EF. So we're just going to get rid of this because it printed wrong. So for this, we are going to write a true proportion based on this information. So we're just going to take what they gave us and we're going to start plugging in the values that are given for that. So we know AC is 12, so we're going to write 12 over, and DF is 18, so we have 12 over 18. And then we also know that BC is 9 over EP. Oh, I don't know why I put a P. That's supposed to be an F. Sorry about that. Which is X. So we know this proportion is true. And again, it didn't print that properly. So once we have this proportion, we can again solve it using cross multiplication. So we're going to take 8 times 9. And we're just going to do that, or 18 times 9, do that math really quick. Which is 162. And that is going to be equal to the product of 12 and X. So 12X. Then we will divide both sides by 12 to get X equals let's see, 12 times 3 is 36, and this would be 6, drop down to 0, and 5. So X is going to equal 13.5. Right. And you can just cross out this bottom part, and we're going to skip that for today. Alright, so that's how we can use proportions to solve for a variable. So again, we're going to add in the fraction bars that got deleted here. It should be JL over HL is equal to JK over KG. So using that information, they want us to find JH and JL. So we're going to find out what these are all equal to. So JL is just this one small portion of this side of the triangle. So to find that, we're going to take the entire length of that side, which is X, and we're going to subtract the part we know, which is down here of 2. So that's going to be equal to JL. Then we're going to put this over the length of HL, which they give us is 2. Oh, sorry about that. And then that is equal to the length of JK of 15 over the length of KG, which is 5. So once we have our proportions set up, we can cross multiply to solve for our variable. So for this one, we're going to take the X minus 2 times 5, and don't forget the parentheses, because if you don't have those, it's not going to be the right answer. And then 2 times 15, which is 30. And when you have those parentheses, you are going to distribute. When you distribute, don't forget that this is a negative 2, not just a 2. So we're going to have 5x minus 10 equals 30. Then we would add our 10 on both sides to get 5x equals 40. Divide by the 5, and that would leave us with x equals 8. Once we have that, we can use this information to find JH and JL. So we know this x equals 8, and we know LH is 2. So to find JL, we're going to take 8 minus 2, which is going to be equal to 6. And JH we know is equal to 8. And there's our answers. All right. We can also use scale factors on maps. And when we do this, we're going to take the scale factor they give us for the map. So in this one, the scale of the map is 1 inch equals 8 miles. So that means every inch on here is 8 miles if you were out in, like, on a street. So we determined that the distance between Westbrook and Cooley is 5 inches. That's this distance. We need to figure out how many miles that is. So we're going to set up our map ratio as a fraction, which is 1 inch over 8 miles. And then we're going to use this distance of 5 inches, and the inches are going to go in the same location. So inches were on the top of our first fraction, that's going to be on top of our second fraction. And then on the bottom, that's going to be what we're looking for. So we're looking for the value of x. So we're going to go ahead and cross multiply and take 8 times 5, which will give us 40, and set that equal to 1 times x, which is x. So the distance is going to be 40 miles from Westbrook to Cooley. All right. The last thing we're going to be talking about is the definition of similarity. So in this, two figures are similar if all angles are congruent, and all sides are proportional to each other. Okay. So when we're writing a similarity statement, the symbol for similarity is this little squiggly sign. So we are going to find the angles that are congruent. In this one, they're just going in the same direction. And when we write our similarity statements, we're going to write them the same way we wrote our congruent statements, by going in the same order. So this one we would have A, B, C, D is similar to E, F, G, H. And those are the same. And then our proportionality statement, we're going to use this to write a proportionality statement. So we can take the first two letters of both and write them as a proportion. So we could do AB over EF. Then we're going to take the next two letters, BC and FG, and write that as an equal proportion. Then we'll do that again and put CD and GH. And then we can take the first and the last letter, AD over EH. So when you're writing these, you want all of the line segments from one shape to be in the same location in your proportions. So AB, BC, CD, and AD are all from our first shape up here that's in red. And then the rest are from the second shape. So you always want to make sure they're in the same part of your proportion. And the sorry about the bell. The difference between these is the similarity statement has the similarity symbol. And then the proportionality statement has proportions set equal to each other. So that's how you can tell the difference between these two. So our next one, we're given that these two triangles are similar. we're going to list all the pairs of congruent angles. So just like with our congruent triangles, the congruent angles are going to be in the same location in the name. So the first ones are going to be congruent, the second ones, and then the third ones. So if we list those out, it's going to be angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. And then we're going to list out the proportionality statements for the sides. So that's just what we went over in our last example with all of the side lengths being written out as proportions. So again, we're going to take the first two of both of them and write them as a proportion. So AB over DE is going to be equal to BC over EF, and then AC is going to be over DF. So the number of sides that are on each shape is how many fractions you're going to have. So these are triangles which have 3 sides, and we had 3 proportions that equal. The first example had 4 sides on each shape, so then we had 4 proportions. Oh, can't write and talk at the same time. There we go, 3 and 4. So that's one way of how to identify how many fractions should be in your proportionality statement. All right, our next example, we are going to determine whether the figures are similar. So if they're similar, that means they're going to have 4 congruent angles between the 2 shapes. And they both have right angles, and then the angles that are congruent to each other in the corresponding spots. So we know all their angles are congruent. Now we need to make sure that all of their proportions are congruent. So I'm going to start with the top of our shape, and I'm going to write a ratio with those. And it doesn't matter which one goes on top for this. And if we simplify this, we are going to get 7 over 4. Then we are going to go ahead and work our way around the shapes with the corresponding parts to make sure that these are all equal to each other. If we find one that is not equal to the rest, then we know they're not similar. But if they are all equal, then we know that the shapes are similar to each other. And in this case, we got 7 over 4 for the first two. And if we do the last one, or the next one, we would have 14 over 8 again, which we already know is 7 over 4. And the last side, again, we have 14 over 8, which is going to simplify to 7 over 4. So because all of these are the same and they had all congruent angles, yes, they are similar. Then we're going to write a similarity statement, and we're going to go in the same order. So working our way around the shape, we can say DABC is similar to MJKL. And that's our answer. Using these proportionality statements, we can also set up some ratios between 2 triangles to find missing values. So we know AB is going to go with DE. And we know that BC is going to go with EF. And then our last side, those are going to go together. So when we're setting up these proportionality statements, we can substitute in the values of what they're equal to. So first, let's solve for x. So we're going to take the sides that are related to x and write them as a ratio of 3x over 20. Then we're going to look at which sides have 2 numbers without any variables. And for that, that's going to be AB and, oh, sorry, not AB. It's going to be BC and FE. Those both have numbers and they are corresponding to each other. So we're going to put 3x over 20 equal to 12 over 16. And notice that the 12 and the 3x came from the same triangle, so that's why they're both on top. Then we can cross multiply, to figure out what it is going to be equal to. And we're going to get 240 equals 48x. And then we will divide by 48. Okay, if we simplify this, divide that by 2 would be 120 over 24, divide by 2 again. And we're going to get that equal to 5. So that would be our value of x. And again, you can use a calculator for this if you need to. So then we're going to do the same thing just for our y parts. So we know 9 and 6y to go together. So we're going to do 9 over 6y. And that is going to be equal to, and again, we're going to choose the ones that have 2 numbers. So we're going to use the 12 over 16 again. Then to solve, we can cross multiply. 12 times 6 is 72y. And 9 times 16 equals 90. 54. It's going to be 144. And then we'll divide everything by 72. And I'm just going to work that out over here. Dividing these both by 2 would be 72 over 37. And divide these both by 9. That would be 8. Oh, you can't divide them by 9, sorry. Let's see if we divide them both by, not divisible by 4. Let's just use a calculator. It's the end of the day and my brain's not working. There we go. So we're just going to do 144 divided by 72. That makes sense. It is 2, which gives us our final answer for this. So that is how you can use these proportionality statements to solve for a triangle. If you have any questions, let me know, and the homework is posted on Schoology, or OneNotebook, and the key is posted on Schoology. Let me know if you have any questions.